Okay, so this session is all about reimagining application networking and security, and I'm going to introduce some new solutions in this space, specifically oriented around cloud-native application networking, as well as cloud-native application security. Let's get right into it. The overall agenda I have, three main things I want to talk about. First of all, how did we get here? Why is there even a need to reimagine the way we've approached application networking and security from what we've been doing in the past 10, 20, 30 years. Then I'm going to deep dive a little more, double click on what we're doing in the application networking space. What are the challenges that are unique to that environment, as well as then what are solutions that we're bringing forward? And then similarly doing the same exercise, but now in the security space. We've been playing, so we at Cisco have been playing in both spaces for over 30 years, so we have a lot of expertise and thought leadership, but how do we apply it to the problems presented in this new cloud native environment? That's basically the running theme that you'll see. And finally, I'll summarize everything and just call out some key takeaways. Let's get right into it then. So how did we get here? We've seen that traditionally, application's been very tightly coupled to hardware. You wanted to spin up a new application, you'd have to stack and rack a new server, install an operating system, and then that would run your app. Well, a big leap forward was when we introduced virtualization technologies that had then the ability to share a hardware, to say, let's virtualize a hardware so that you could run multiple applications on the same physical hardware. And that way you didn't have to have a second or third or multiple instances of actual physical hardware per each application, so that as you scaled up and scaled down, you maintain a lot of efficiency. However, this approach, while it's very flexible and extensible, it did require a lot of extra overhead. So if you see here, we have multiple layers of abstraction in the forms of an operating system for the hardware itself, as well as virtual machine operating systems. All of these then would have to be licensed. All of these then would have to be patched, etc. There was a lot more extra overhead, as well as then ultimately the performance overhead, because you're going through all these layers of abstraction. So an improvement was made here by virtualizing not the hardware, but the operating system itself. This was the approach used by containers, and it's far more efficient, far more effective, and then it really led to a change in how applications themselves were developed. For instance, instead of having what are now known as monolithic application architectures, where every component within the application would reside within the application, you have these huge libraries and files, etc. Well, all of these then could be split apart into atomic parts, self-contained and containerized individually, but then interconnected, either with application programming interfaces or direct protocol connections like TCP or gRPC or whatever the case may be, really doesn't matter. But the point is that this way you could bring a lot of benefits. For instance, you don't have to upgrade an entire application all at once. You'd have benefits such as portability. You could have some of these services running on-premise, or some running in the cloud. Or you could have some of these running in one cloud provider and another in another cloud provider. You have maximum flexibility that way. You could also ensure continuous delivery. You say, okay, I want to upgrade one service. Well, traditionally, when we upgrade an application, you'd have to take it down, you'd have to install the update, boot it up, and then you'd have this planned outage. Well, you can do this continuously now by saying, you know what, if I'm upgrading a specific service, when it's ready, I spin that up in a container and I just change my pointers. Rollbacks are just as easy. Let's say there's an issue with version 2.0 of this ML app. I just roll that back to 1.0, and again, it's instant. And then when I'm ready for my modified upgrade, I just go ahead. So tremendous amount of availability realized through this continuous delivery architecture. Not only that then, but scalability itself. So when we containerize these services, we can describe this entire application environment in a YAML file. We feed that into Kubernetes, which in turn wraps all these containers and pods, and then manages the orchestration via a control plane that says, you know what, I'm going to assign work to a series of worker nodes, and I will spin up and spin down the services as I need them, dynamically and continuously. And per my application requirements, or even per the health and availability, maintaining the environment to whatever was declared in that Kubernetes file. Okay, so that's just a very, very high level overview of how the application architectures have evolved. It's very simplified, but it's just for the point of laying some context for our discussion now to follow. So as we go and look deeper into what are the challenges that are presented with these new cloud native architectures specific to networking, and then we'll repeat for security, at least there's some context laid there. So as we brought out, we said, okay, now we have all these microservices within an application, all needing to be interconnected. And these may be on-prem, they may be in the cloud, they may be in different cloud providers. There's all sorts of variations. Now, all of these then, these interconnections have to be managed. And these are net new interconnections because previously, all of these services would be on a single server. Virtual or physical, it doesn't matter, but you wouldn't have to interconnect them. So now, in addition to providing and managing all your external connections, there's a whole new series of internal connections that need to be similarly managed, that need to be authenticated, that need to be encrypted, that need to be observed, and the traffic and the loads need to be managed on these, et cetera, et cetera, et cetera. So all the application challenges you have are now significantly increased, doubled, maybe even more. It all depends on the complexity of the application architecture itself. Okay, so this is time consuming, obviously. This is error prone. It can, if it's done individually, it can lead to a lot of inconsistencies, etc. Enter then the service mesh. So many customers have found that this is a valuable way then of in maintaining consistent security. You have one set of encryption policies for your entire cluster. You have the ability to observe the traffic pre and post encryption so that you can see what's actually going on. You can manage the traffic according to your loads or your policies, etc. And so a lot of benefits are presented with the service mesh architecture. Istio being one of the most popular, but there's others like Linkerd and so on. But service meshes, like many technologies, they present some great advantages, but then at the same time, as we continue to push the envelope, are presenting challenges themselves. So some of the challenges that I'm going to talk about are the lifecycle management of the mesh itself, how that introduces a lot more work than was previously needed for managing network connections, observability challenges, as well as multi-cluster challenges and advanced use case challenges. So I'm going to deal with these one at a time. Let's start with the lifecycle management. In a network, if you wanted to have more functionality from that network, well, then you'd have to upgrade the devices that constitute that network, the routers, the switches, etc. Get the latest software versions on them, and then you have the new capabilities. You might have to do this manually or more recently using controllers that would manage the software so that you just have everything all kept to a single standard, golden images, etc. So you can automate that. However, it might be tempting to think that, okay, then if I want to upgrade a service mesh from one version to another, it's the same exercise. I just, upgrade my mesh and I'm done. Well, not quite, because there's a cloud native principle of immutable infrastructure, which basically says once you establish the infrastructure, which includes the mesh and all the interconnections, it cannot be changed. And as such, we have to use a new approach. And the new approach, the way I like to liken it or compare it is to changing a tablecloth on a restaurant. Say you're at a fancy restaurant and you've been eating, you have all your plates and your wine and etc. all on the table, and the tablecloth, maybe some wine spills on it. Well, how do you replace that tablecloth? You don't just rip out the old one and try and get a new one and maybe fasten to the old one as you rip it out. No, what you do is you set a new table is set. So an entirely new table with the new dishes, with the new wine glasses, everything is moved over. And once it's in place, then actually you also get moved over. So it's the same way with a service mesh. You lay out a new mesh, you lay out new instances of the services on that mesh, and then when they're ready, then you gradually redirect the workloads to the new mesh when the confidence is there that everything's working as it should be, and everything is looking good. You can decommission the old mesh. It's a lot more complicated. And then when you think about that, when it comes to service meshes, they typically only have 3-month life cycles with only 2 supported versions, the current version and the previous. So if you have a production environment and you want to be on a supported version, this forces you to upgrade your mesh every 3 months. And this is done on a cluster by cluster basis. We deal with customers that have dozens, if not some have over 100 clusters that they're managing. And as such, that presents a lot of toil. So being able to manage that in an efficient and automated manner is very valuable and can remove all that toil. A second area of challenge that we want to touch on is observability. There's a lot of great tools out in the open source community to give us observability. So you have Prometheus Grafana for metrics, you have Kiali for topology, you have Jaeger for traces. But then if you're troubleshooting as an operator, you have to constantly go from one pane of glass to another pane of glass and stitch all that information together. It can really slow down your troubleshooting, and it makes it much more difficult. Whereas if you have to repeat, and all of these tools incidentally are cluster by cluster tools. If you have multi-clusters, then to correlate that information, aggregate that information, and then integrate that information are presenting some real challenges so that you can troubleshoot as efficiently as possible. Also, I talk about advanced use cases. So for instance, we have what I displayed earlier when upgrading to one version of a service to another I illustrated what's called a blue-green deployment. It's just a simple digital cutover. It was pointing here, now it's pointing there. Now, there's a way that this type of upgrade can be de-risked, and that's termed canary deployment with traffic management. So rather than just sending all of the traffic to the new version of the service, we could manage. We say, hey, why don't we start out just sending 20% of the traffic to the new service, see how it performs, see if there's any unexpected issues, and then as our confidence level increases, we increase the amount of traffic that's directed there. Another advanced use case is the circuit breaker use case. And that is now not managing versions of an app, but the service itself and monitoring its health. And say we can set thresholds and say below a given threshold, if the health of that service degrades or deteriorates, we're just going to cut that service so that no more workloads are directed to it and thus receive a poor application experience. As such, we see that when managing a service mesh, your management solution has a number of requirements: the basic lifecycle management, managing the security and the encryption of the mesh, provide observability, optimally and integrated observability like we're talking about, learning about the environment so that you know what is normal and what is abnormal, and you can set service level objectives, and then enabling advanced use cases like circuit breaking or canary deployments, etc. And so to this end, we have a solution service mesh manager that not only meets all these requirements, like there's a few other offerings too on the market, but also has a number of unique differentiators. And again, this is where we're bringing, for instance, our 30 plus years of networking experience to now the cloud native domain. For instance, one of the things that we do that's completely unique is to be able to support active control planes. To say even across service meshes that span clusters, instead of just having a single primary, like a hot versus a standby control plane, we can support a multi-primary control plane, which means both control planes are active, and that maximizes the redundancy of that service mesh even across clusters, as well as takes care of all the service discovery, et cetera. We're the only ones that can do this. Or for instance, taking advantage of our years of expertise in providing multi-tenancy, segmentation, segregation solutions to recognize that Okay, there could be there could be multiple customers leveraging these same resources, or even departments, or any other logical group. How do we maximize the flexibility of how the traffic is separated across shared resources, even in these type of environments? And so we're the only ones that support multi-gateways per service mesh per cluster, as well as direct connections, so that you could have an external client connecting directly to a workload. The maximum flexibility when it comes to these types of interconnections. And then also, we have support for asynchronous microservices. We see that service meshes typically are optimized for request-reply communications, which are um, synchronous communications, whereas there are some communications and some applications, notably Apache Kafka, that are event-driven. So when something happens, then communication is triggered, and it's not synchronous. And as such, some competitors or some others have used an event mesh approach to say you have your service mesh for your synchronous. Now we have a completely different mesh for asynchronous apps, whereas that's very redundant. That's a lot of extra architecture and infrastructure to lay. Whereas what we do is we optimize, and we've optimized, for instance, specifically Istio Service Mesh to support both synchronous and asynchronous communications. And again, we're the only ones that have done this. So a lot of specific key differentiators in this space. Let me now show a demonstration of Cisco Service Mesh Manager.
So let's take a look at Service Mesh Manager. Service Mesh Manager is an Istio distribution, an enterprise-grade Istio distribution that enables you a lot of additional features that you wouldn't get with just basic out-of-the-box Istio. We get advantages in terms of mesh management, integrated observability, and advanced use cases like traffic management, circuit breakers, or canary deployments. We're going to look at all of these in our quick little overview. Here's our main dashboard. We see we have 2 clusters, 18 services, 11 workloads. Most of them are healthy, but we have some issues. We don't want everything green for the sake of this demo. It's more interesting. It gives us these high-level stats of our overall environment, but it's particularly more interesting once we look at things in, say, a topology view. With an open source tools, you would have to use, say, Kiali for your topology view, and then Grafana for metrics, and Jaeger for traces, and it would be cluster by cluster. But here, everything is integrated, not just for the sake of observability, but also configuration. So I see my overall topology. I have a multi-cluster topology. I have a master cluster, and I have a follower. They both happen to be in the same cloud provider, in this case AWS, but they could be on-prem, they could be in different providers, etc. It doesn't matter. I get the bird's eye level view of everything. I can zoom in on any given item, whether it's a service or a workload, etc., and I have a tremendous amount of information. The overall health, this one is a very healthy service, any service level objectives I target, the overall key metrics. From here, I could launch, for instance, I could launch a Grafana dashboard for specifics about the given service or the object that I'm looking at, or I can even launch Jaeger if I like. But having everything integrated gives me a lot more comprehensive information that's around that object without having to jump between tools. So I can not only, for instance, get a view of how things are doing, but I can also change things. For example, if we're talking about mesh management, I can do things like inject faults. Like for instance, if I want to take a look, I saw that this service was very healthy, but what if I start injecting a fault into it on purpose to get a sense of, okay, what is that going to do to my overall environment? I'm going to say, okay, 100% of transactions will now receive additional 2,000 milliseconds of latency, 2 seconds of latency. What's the effect that that's going to have on that service? Well, I can now come over to health, and then within a few moments, I'm going to start seeing the effect of that, particularly when I see latencies between clusters. I'm going to see that I'm getting this spike here that's going to just continue rolling out in real time and then overall degrade the performance and thus the health metric of that particular service, and I'm going to see the effects of that in my overall reporting. And on my dashboard, you can see here the spike in latency that I've injected. Now, I can see things and configure things from this dashboard, but I can also have a timeline view. So for instance, I can see things not just how they are, but I can go back in time, whether it's a topology view or if I want to maybe zero in on specific services or workloads, I can not just see the state of affairs right now, but if I look at my timeline graph, I see that back here, I did have some issues. So I can go back in time. I can say, okay, what was the issues that I was experiencing there? And I can delve further into them. So for instance, I can see that the booking service here had some health issues. The error rates were fine, but the latencies were in the medium range, as well as some of the error rates were quite high. So I can see what happened even in the past. So it gives me a tremendous amount of visibility into the overall health of my environment. Not only that, but if I return back to, say, my topology, I'm going to go live, come back to my live view. I'm going to see that that service that I injected the fault is slowly turning to a lighter shade of green. It's going to eventually turn yellow and then orange. But some of the other things that I can do with my Service Mesh Manager is to even direct traffic to align to, say, my overall use case objectives. For example, I have here 3 versions of the movies service, version 1, version 2, version 3, and right now by default it's about a 33% mixture of traffic for each of these. But I might say, you know what, I might want to have the majority of my traffic still going, let's say 60% of my traffic to version 1, 30% of my traffic to version 2, and only 10% of my traffic to version 3 to have like a canary style deployment so that I'm testing the new versions incrementally without sacrificing the user experience. And then as I gain confidence, I can, adjust and move the entire load over. And this is certainly certainly easier to do than doing it via editing the YAML files, such as if I'm working just with Kubernetes objects like this and I require a lot more expertise to go in, but then I'd be changing weights such as highlighted here in the appropriate fields, but it's just simply far more user-friendly and allows for this type of policy to be set by even non-experts.
Okay, let's shift gears now and talk about application security challenges and solutions. So the same exercise, but now instead of just focusing on networking, let's look at general approaches and challenges for security. Now, in a traditional approach, when our applications and the data for the applications all resided on a single server, when it was tied and coupled very tightly to either physical hardware or virtual hardware, it was very easy to protect. We just throw in some firewalls in front of it. Even if the application itself was lacking in security functionality, we could compensate via the network. One approach would be, like I say, to throw some firewalls in front of it. Another approach, if there wasn't any native encryption, we could provide encryption again via VPNs, virtual private network headends, on the network, and therefore take care of that and compensate. But again, this is our new environment, the cloud native environment. Applications, where are they existing? Because they're so dynamic and ephemeral. Where do we put the firewalls? Where do we put the VPN headends and terminates? And how do we manage then all of these flows and ensure security? Not only that, but I presented, again, a very simplified view of microservices and interconnections. But the reality is they're far, far more complex than this. For example, here's a microservice dependency graph of just one application, a banking application by Monzo. Or what about some bigger apps like Netflix? This is a microservices dependency graph for Netflix. And then even more scary becomes the microservices dependency graph of Amazon. These just become mind-boggling in complexity. Where is the perimeter of this application that you stick firewalls around it? Or how do you manage all the dependencies in such an environment? These are the new challenges that are presented in cloud native. First of all, recognizing that we have new security challenges as part one. Then the biggest thing, or the thing that's most lacking often that we hear from customers, is a lack of visibility. We just don't even know what's going on, and we don't have that insight. Also, recognizing there's multiple layers of security needed, from the containers, the libraries, the dependencies, the roles, the orchestration, etc. All of these layers, and even the APIs, there's so many elements of security that need to be examined, inspected, and provisioned for. And finally, also recognizing that the earlier in the development process, specifically the continuous integration, continuous delivery process, that we can identify security risks or threats and actively address these, the more efficient and more cost effective and the better for everyone. There's so much time that could be saved if you spot these earlier in that cycle, and so much frustration as well. So to that end, we have an offering, Cisco Secure Application Cloud, that provides these needed capabilities: visibility, policy enforcement, shifts security left, and I'm going to talk about that in the very next slide, as well as then offering this continuous security in a cloud native environment. So what are we talking about when we say shift left? Well, some analysts have really coined this term, and it's become popular, but maybe not everyone is familiar with it. The idea is that here we have the CI/CD lifecycle. Many security tools are oriented towards the runtime. So once the application is up and running, then we think about security. Then we take a look at tools that address security. Whereas, what if we can move that left in that cycle to say, okay, no, don't just give SecOps tools, let's also give the DevOps team some security tools so that they can make good, security decisions, apply good security hygiene. And you know what? Not only them, but even the developer. And we're going to talk about, for instance, how we can enable the developer to to facilitate and take security into account in the decisions they're making, so that right at the start, when they're coding the app, they got security built into it rather than after the fact investigation that now has to result in application patching and recoding, etc. So we want to shift left and make it continuous. That's the goal of Cisco Secure Application. And what I really like about the architecture that's been used here is that a lot of competitors use an agent-based architecture. Now, what does that mean? Remember, we talked about Kubernetes environment where we would have a control plane and worker nodes, and they would then apply security agents on all of these worker nodes. Now, this approach, it's not very efficient because now you got a lot of extra software, kind of like one of our earlier slides that showed all the levels of abstraction that was in a virtualized environment. You got more software that has to run in order for the applications to function, and this bogs things down. It puts additional load and expense onto the overall architecture. In contrast, we leverage native capabilities that are already existing within Kubernetes, specifically the application controller capabilities of the Kubernetes API server. And as a result, the only dedicated resource we need in an entire cluster to run this security solution is a single pod. So that's very lightweight, that's very high performance. Like I say, to enforce a policy, we use these native mechanisms, so it's fully secure and a lot of fantastic capabilities, and it scales, and it's very inexpensive then to the environment. Also, we can optionally integrate with Istio Service Mesh. So we talked about the benefits of a service mesh. So by applying a sidecar like Envoy, a proxy, then we can have some additional capabilities for each application, such as giving us observability, providing us with firewalling, providing us with encryption, etc. And then these services are typically managed by the control plane of the service mesh. So there's central policies that are applied to all, and it makes it scalable, manages the traffic, manages the security, manages observability, etc. Now, we patch into this by adding an additional module within that Envoy proxy, as well as then some additional code to provide DNS detection so that we can even set policies that are limiting which domains that can be connected to by the workload and report that up to the controller to enforce policies of that nature as well. And then finally, remember I talked about we also want to arm the developer to help them make security-aware decisions early in that life cycle, in the development phase of the CI/CD life cycle. So we really want to shift left. How do we do that? Well, one way is that we collect information about various APIs and their respective security vulnerabilities, threats, posture, etc., from many sources, from our own Cisco Talus, which is one of the most comprehensive security resources in the world. We do about 5 times the amount of security analysis of events per day than Google does searches. And not only that, we gather information from there, but also from Cisco Umbrella as well as BitSight. And then all this information is then fed to our system that says, okay, these are the APIs that we know to be secure or know to be not secure. And therefore, we can present the application developer a curated list. They say, hey, I need an API that does this. And rather than just, first come, first serve, picking an API that meets their needs, which is typically the approach, I presented that security-aware curated list to them, they can choose not only the API that meets their needs, but the most secure one. And you can even set specific compliance rules, like the API must meet this, that, and the other thing, and these can be set globally. So we can ensure that even in the development process, but not just there, we can also observe the traffic that's traversing these APIs, monitor that traffic, and if any of the policies or compliance rules are violated, we can immediately take action up to and including termination of that traffic as well. So many different options available to us via this technology. So not only presenting container security, but also API security. And we, Cisco, are unique in this overall offering. Let me now share a demonstration of Cisco Application Cloud. Before I get into the demo, I want to call out this website, this URL, eti.cisco.com/appsec. So emerging technologies and incubation.cisco.com/application security abbreviated. And this is where this very software is available for free for anyone that wants to run this demo, or even better, to run this solution in their environment. There's no feature limitation, there's no time limitation, the only limitation is scale. We support up to 5 nodes for free. We want everyone to take it for a test drive to see container, serverless, API, and service mesh security in action in their own environment. So let's get into the demo. When we log in, we're going to see a dashboard like this that identifies the top security risks, whether the top risk from pods or APIs or vulnerabilities or permissions, whatever the case may be. Or for those who prefer, we also lay out this security information in the MITRE framework. So you can see all the different attack vectors, as well as then all the security best practices that are recommended to prevent those specific type of attacks. But even more than just informing us of a particular vulnerability, such as in this case, the ability for attackers to hide their tracks and cover over their activities, we see what are all the affected elements with our environment that are that would be affected by this specific vulnerability. But what I really like is how easy it is to repair, to say, okay, I get it. There's a vulnerability I have here. There's some best practices that haven't been implemented. Is there anywhere I don't want this implemented? Probably not. And then I just apply now. And then I've gone and I've created the rule to prevent defense evasion. And then now I can see even that specific vulnerability is plugged. Now, not only can I see my threats as outlined, but I can see my overall environment from more than one perspective. For instance, if I'm a DevOps person, I might be interested, I'd likely be interested in seeing my clusters and pods and interconnections, etc. But if I'm SecOps, I can just quickly change that view over here. And then now I have a view of the same environment,
but from a security perspective. I see what pods are at risk or the connections that are regular versus encrypted, if there's any blocked traffic, and I can zoom in on anything according to my interest. Not only this, but then I can do runtime security and see, okay, of my workloads that are running, which one of these are at risk? And for instance, I can see that this Nginx workload is quite risky. And why is that? Well, because it's privileged, it can run as root, and it's public facing. For a lot of errors and vulnerabilities associated with this workload, and therefore I could set policies to restrict these types of risky workloads from running or having other actions taken as a result too. Or APIs. For instance, when I come back to my security risks, I can identify which are my top security risks from an API perspective. And so if I take a look and drill down, I can say, okay, what is risky about this particular API? Well, I focus in on its security posture from a network or application or DNS perspective, and I see from a network perspective, there's a vulnerability, and the specific vulnerability is it's using a deprecated version of TLS. This leaves it susceptible to man-in-the-middle attacks such as Poodle and Beast. I can even identify the specific endpoints where this vulnerability is present. Now, I might set compliance rules, so either on my connections, my clusters, pods, etc., and even my API policies. So for instance, I might have a policy that says, okay, I'm only going to allow API policies that are specified as low risk according to all these sources I have, Talus, Umbrella, and BitSight, etc. Or it can even get very granular and flexible. For instance, I might have the new policy that says no Russia based APIs for the time being. So to implement this, I'll say, okay, I'm going to look at all the API endpoints. I'm going to select an attribute such as location, and I'll say it is not equal to, and then I'll punch in Russia. And now I've got a tag that will look and will geolocate those APIs and then can enforce them to say, okay, I'm no longer leveraging or utilizing even APIs based on specific location, as well as any other criteria. So basically, I have very powerful tools for applying security in my cloud native environment, whether it's container security, API security, serverless security, so on and so forth. Very comprehensive, powerful tool, and it's free to use, so by all means, take it for a spin.
Okay, let me wrap things up and summarize the key points that we've covered. So first thing, cloud native architectures, they bring many business benefits. We talked about portability, flexibility, scalability, continuous delivery. All of these benefits very valuable to the modern application development and experience. Not only this, but these architectures do present some new challenges, which is almost inevitable with technology. You solve some problems, but sometimes you create some new ones. And so we're applying our, like I said, our 30 years plus of experience in networking and security to this new domain, these new set of challenges, both from cloud native application networking and cloud application security. And the two specific solutions I introduced today were Cisco Service Mesh Manager and Cisco Secure Application Cloud. And what we really like, what I really like about the approach we've taken here is that we really want to drive adoption. We want people to take these for test drives. So we're offering these software suites completely free of charge for people to try. And it's got full functionality, no time limits whatsoever. The only limit is the scale. So 5 nodes for Secure Application Cloud, 10 nodes for Service Mesh Manager, and then at these steps, you can just start using them. You download, you log in, you get an account, you sign up for, like I say, completely free, and you're off and running within a few minutes. Same with Service Mesh Manager. So we really want people to try and adopt and then see the value that we're bringing here based on our expertise and thought leadership into these new spaces, and we really want you to take advantage of that. We're part of Cisco's research and development team, which is called Emerging Technologies and Incubation. If you're interested in following some of the other tools and technologies and solutions that we're actively working on and developing, please feel free to follow us here at eti.cisco.com. Thanks so much for taking the time for this session. I hope you found it useful.